Welcome back. In this lesson, we're going to look at mass movements of soil and rocks as gravity pulls huge sections of the earth around. So anything that's on a steep hillside can be pulled by gravity. If it's loosened at all, any way that it's lubricated, whether there's water or ice involved, or simply just too steep of a surface, so that as it is piled up, it eventually becomes unstable and starts to fall, you're going to see that the landscape everywhere is carved by these mass movements. You're going to have rock falls and avalanches and mud flows and volcanic flows and all kinds of things that's going to happen as a result of gravity. So let's look at some of the examples. So mass movements are anything that is falling down the slope of a hill due to gravity. So mass movements can be very, very quick, like an avalanche. You could have 100 trillion tons of snow all coming down a mountain all at once. Or it could happen very slowly, eking down as the one particle rubs against another in, say, dirt or mud that's on a steep hillside that's slowly slipping down, almost like a glacier would move. Okay, so it works all at once, or it works over a long period of time. So what would cause it normally is something that is going to act to slicken the particles. So anything that lubricates the dirt particles or the rock particles or the snow particles to make it slippery enough so that there's no friction holding it in place is going to trigger or contribute to a mass movement. Then there is the idea of a trigger. What could cause an impetus to give all of that enough energy to fall all at once or to begin falling? There are some triggers. So we'll look at the types. So the types, the first type is a very slow. It's called creep. Okay, so if something creeps, it's a really slow, steady downhill flow. So any material, rock, soil that has been loosened from a previous rock that can then fall, even if it's falling very slowly, is called creep. Okay. Solifluction is kind of a type of creep, but what's happening is that the ground is frozen. So if the ground in, say, the subarctic regions, northern Canada, Norway, whatever, are frozen, okay, which resists flow, and then it melts. Okay, so if it's melting, you've got a way, like a slickening of those materials, and so some of the ground is partially frozen, some is not. So it's not going to act all at once because it's got a little bit of resistance, but it'll little by little flow. And so solifluction is soil flow. It's the idea of soil flows. Then if you do have a flow, normally it's almost like an avalanche, but it would be of mud or of something that is nearly liquid in how it works. Okay, so you can think of thick liquids as flowing. So you can have mud flows. All right, so a mud flow, as it's going through, if you have lots and lots of rain on a steep hillside, especially if there's no trees in that area that's holding it down, or that you have really close bedrock to where there's not lots and lots of permeation of the water. So the water doesn't go deep into the ground, it only goes shallowly in the ground. Then there's too much. Then all of that can turn into mud, and then the mud can flow. Okay, lahar is a specific kind of mud flow caused by a volcano. So imagine that you've got lots of snow on the top of a high mountain that happens to be volcanic. Well, that snow is probably fine where it is, except that if you start having a heat source right there, it's going to melt all that water. Now you're going to have a tremendous amount of water all at once. That water is going to mix with whatever soil is on the surface, turning into mud. And that mud flow is not just mud, but it's also volcanic ash all running down, and that's called lahar. Lahar is ridiculously destructive. First of all, you can't escape it. It's running faster than you can, and it like clogs everything. It would be really hard for something to grow after a lahar flow. Now, slides is you have this idea that it's not necessarily thick fluidy, but it's just all fragments, all pieces. So you can have rock slides where somehow there is enough steepness to that, and there's something that's triggered, and all the weathered pieces kind of fall all at once. Things that have been kind of holding on kind of break loose, and then it falls into something else, and there's a chain reaction, and then a lot of rocks slide at once. You have that along highways where you have falling rock, where they've tiered it so that it's as safe as can be, but still weathering is going to loosen rocks and boulders at the top of these high walls that could then fall. And a big rock falling on small rocks is going to make all the small rocks fall. All of that accumulated can make even other rocks fall, and so you can have huge slides all at once. Okay. Slumping is when you have essentially ground, so it's not acting like mud, but it's huge pieces of ground, and it is too steep. And if it's wet enough, then whole sections will kind of act like a spoon and basically kind of fold itself down. So it slumps down like if you're slumping in your chair. Okay, so if you have very steep hillsides, especially kind of spoon-shaped hillsides that maybe have already had erosion, and then you have too much rain, you could have a whole area slump. And that's pretty bad if you've got houses and stuff at the top of that. Avalanches, I think of avalanches as being snow. Really steep, it snows and is precariously perched, and then some kind of an event triggers it, and then it all comes rushing. And then, of course, snow rushes into snow and knocks it loose, and then it all comes down all at once. Rocks can do the same. Soil can do the same. Okay, so all of this can be similar in your ideas. Now, the steeper the slopes, the more likely it is for these rock falls or these snow falls. So maintaining them, a lot of times, if the high ski patrol will cause small avalanches that will not be dangerous, so that it doesn't pile snow that can then be catastrophic. So you can also get water out of the way, since water is a big